Hello everyone, today we'll be solving finding the max length of a valid subsequence. So I've already solved it a few days ago. Let's check this out. You are given an integer array nums of a subsequence. It's valid if it satisfies uh, sub 0 plus sub 1 mod 2 is equal to sub 1. Okay, so this the modulus of the sum of these two and the sum of next two should be the same if it's valid. Okay, okay. A subsequence no elements without changing the order. Hmm. Okay. So mod 2. Okay, so the first thing that comes to my mind is uh, when you add two digits, they either have to be the sum has to be either even or odd. And then if it's uh, so we only have two options here. So the sum of every uh, let's say we have the subsequence this thing. So give me a second. Yeah. So if this is our subsequence, um, we have to go through two cases. The first case would be the sum is an odd number. In the second case, the sum is an even number. Okay, and then we can start with let's say we start with one. If we're calculating the odd sum, we add two, and then one again, and then two, and then one again. So it would be one, two, one, two, one. And it would make no sense to exclude this and try finding it out, right? So yeah. And if we're starting from if we're considering an even number, then okay, then it would be one, 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 or two, two, right? Okay. Hmm. Oh, supposed to return the length of the substring. Hmm. So let's run over our first loop. Let's consider the sum to be an odd number. So in that case, so if our sum is an odd number, then m1 is equal to 0 for I for n times. Yeah, for n and num, um, starting from the first index. So we can add, or why overcomplicate things? Let's just say for I in okay. Okay, yeah, moving on. So, so for I in range 1 to n, we check, let's check the previous element. Um, we do need a previous, right? Previous is equal to nums of 0. So if nums of I plus previous mod 2, basically we're checking if it's an odd number, then previous would be nums of I, and then result, what result? M1 plus equal to 1. M1 is initially 1, right? Subsequence is valid. So if it has only two elements, it is valid. If the subsequence has two elements, it's valid. Okay, right. Um, so this is if this is for the odd sums. 1 plus 2, 2 plus 3, 3 plus 4. So let's just check if it's working for the first test case at least. Yeah, so we are getting it right. And now we need to check considering even okay. Okay, if the sum has to be an even number, then you either add an odd number with an odd number, or you add an even number with an even number. So basically, we have to find the number of even numbers and the number of odd numbers in this array. So m2 comma m, I think we can do that in the same loop, right? Uh, let's just do it regardless. So m2 comma m3 is equal to 0 for n terms. If n mod 2, so if it's an odd number, then we increment one of them, and if not, we increment the other, right? So mv plus equal to 1. And we return the maximum of m1, comma m2, comma m3. And that should ideally give us the right answer. Okay, there's something wrong here. Okay, so here the answer should be 1, 2, 1, and then 2, 1. So why am I getting 7 first of all? So current m1, comma m2, comma m3. Okay, first number is 7. So 1, 2, 3, 4, 5. Um, let's let's just print out what our previous is here every time we're let's print it out here. Okay, so 2, 1. Okay, this is where we're going wrong. So if nums of I is previous comma nums of I, right here. Right. I think I forgot the bracket here. Maybe that was the issue. Because yeah, the hierarchy of the operators. So yeah, now this should be the right solution. Where's the yeah, there we go. So basically what we're doing here is um, in the first loop, we are assuming the sums are odd. The the adjacent sums and the subsequents are odd numbers. So for that, yeah. I'm just counting. I'm starting with the first number and then counting the length of the subsequence, the longest subsequence. For the other two cases, if the sum is even, either all the numbers have to be even or all the numbers have to be odd. So once you make that observation, it's pretty simple to solve. Thank you for watching.